Welcome student. So welcome to the today's topic, Ohm's law and combination of resistors. So first we will discuss about Ohm's law. What it says. It says about the current, potential difference and the resistance of a conductor. What is the relation between these three quantities? Okay. So suppose this is a conductor. Okay. This is a conductor. This is a conductor. This is a conductor. So it can conduct electric flow. This is conductor, it's fine, but it has some resistance as well. Okay. It has some resistance. Suppose the resistance be R. Okay. Now what we are going to find, Ohm's law is all about the relation between the resistance, the current and the given potential. The relation between these three quantities. Okay. So this is the resistor. So we have to apply potential difference across this conductor. Okay. So we will connect two wires and finally we will add a battery or EMF electromotive cell or a cell battery which keep the potential difference constant. Okay. Suppose the EMF or the potential difference that it provides across the resistor is V and some current I is entering into the resistor and it's also coming out from the resistor is I. Okay. What Ohm's law says, it says Ohm's law. What it says if the temperature is constant, when temperature is constant, the resistance of the resistor usually do not change. The resistance of the resistor do not change. It is constant. Okay. So when the temperature is constant, the current flowing through the current flowing through the resistor is directly proportional to the potential difference that is, in our case it is denoted by V, the potential difference applied across it. Okay. So the current is denoted by I is proportional to the potential difference V. So mathematically it says the current is proportional to the potential difference applied across it. Okay. Now using mathematics we can write that V proportional to I. Now if we want to replace this proportionality constant by equality, then it will be V is equals to I and some constant, and that constant, the proportionality constant, is R here. Okay. So we will write that V is equals to IR. So V is equals to IR. This is the mathematical equation that everyone remember. It is your task also to remember that V is equals to IR. This is the mathematical expression of Ohm's law. But as it is V is equals to IR, after few days you make, there is a probability that you will make a mistake. You will say V proportional to I. No, the Ohm's law says I proportional to V. Here the independent quantity is V and the dependent quantity is I. Okay, don't make this mistake. Okay, so V is equals to IR, fine. So our task is now we will see an example. Okay, example, suppose if 5 volt is applied between the two terminal of a 10 ohm resistor. Okay, 10 ohm resistor. The question is find current. Find current through it. This is very simple. How to find it? We have the formula V is equals to IR. According to the question, V is 5 volt and the resistance R is equals to 10 ohm. And from formula V, I is equals to V by R. V is 5, R is 10, that is 0.5 ampere. The unit of current, as you know, ampere. Okay, so this is what the Ohm's law. Okay, now our next topic is combination of resistors. There are usually 3 types of combination, mainly 2 types. Combination of resistors is mainly 2 types. One is series combination and the another is parallel combination. And the third one, which is actually the mixture of the series and parallel. Okay, mixture of series and parallel combination. Fine. We'll be discussing one by one. First, we will discuss series combination. Okay, we'll first discuss series combination. What do we do here actually? Suppose you have few resistors and they are connected in series combination. Few resistors, let me draw them first. Suppose this is a resistor whose value is R1. Its 2 terminal is this one and this one. Now you have one more resistor which is connected end to end with R1. That is, this is a resistor. Sorry. Yes. This is resistor whose value is R2. Okay. One more resistor. This is here. This is also a terminal and this is R3. What do we see here? See, suppose this is point A, this is point B, this is point C, this is point D. Here the R1 at B point, the end of R1 and it is the start of R2. Okay, so that's how when this type of combination, we call this type of combination as series combination. Okay, this type of combination is series combination. What we will find, see, suppose a potential difference is applied across these three resistors. Suppose the potential difference I apply is, suppose V. The potential difference which is applied across them is V. Okay, so these are connecting wires. The current will flow through this direction and will come out in this direction. What we are going to do, we are going to find the equivalent resistance of R1, R2, R3 when they are connected in series combination. Equivalent resistance, that is, suppose this is a resistor and it acts as the R1, R2, R3 in series combination. This is point A, this is the same point D, and the battery is connected like this. This arrow is disturbing us. Okay, that's how. Here we will replace this battery. Okay, the same potential difference. Try to understand what we are doing. We are just trying to find out the equivalent resistance R, as it is in series, so I will represent it by RS. Okay, it is in series. The role of R1, R2, R3 in series combination and the role of RS is same. RS is doing the same job as R1, R2, R3 is doing in this combination, series combination. Okay, how we will solve it? How we'll find out? See, suppose the potential difference across the resistor R1 is V1 and the potential difference across the resistor R2 is V2 and the potential difference across the resistor R3 is V3. This V1, V2, V3 will definitely give V as they are connected in series, isn't it? So we can write that V is equals to V1 plus V2 plus V3, no doubt. Yes, no doubt. So this V can be written as, see, the current that is flowing is same. The same current is flowing. Okay, so V can be written as IR series from this circuit, equivalent circuit. It is equivalent circuit. Okay, from the equivalent circuit we can write V is equal to I series, V is equal to I into R series. What is V1? V1 is nothing but from the Ohm's law. From Ohm's law, you can say, see, the current I is flowing through this R1. From Ohm's law, we can say, see, the current is flowing through R1 is I, and the potential difference across V1 across R1 is V1, and the resistance is R1. So what is the relation between these three? The V is equals to IR, current I, R1. What is in case of V2? Similarly, using the Ohm's law only, we can say V2 is equals to I R2. The same current is flowing through R1, R2, R3. Okay, so V3 will be I R3. Now, from the both side, I will cancel out. We will have only RS is equals to R1 plus R2 plus R3. So I discussed here the series combination of three resistors only. If I would choose n number of resistor in series combination, then the equivalent resistance will be equivalent resistance for n resistors in series will be what? R series will be then R1 plus R2 plus R3 plus dot 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 plus Rn. Okay, I hope the concept is clear now. So this is the series combination, equivalent resistance for series combination of resistors. Okay, so this was series combination. Now let us take some at least one example. If I give you one example, numerical value, suppose 2 ohm, 5 ohm and 6 ohm are connected in series series series. Let me ask you here multiple questions. First, find equivalent resistance of them. Second question, corresponding to the Ohm's law that I discussed the first topic, uh, what will be the current? So I have to add here one more information, are connected in series and some I have to provide some potential difference, and 5, 6, 7, 8, 9, 10, 11, 12, 13, and suppose 26 volt is applied across them. Now let us solve it. See, the question says 2 ohm and 5 ohm and 6 ohm. These are the resistances. 2 ohm, 5 ohm, 6 ohm are connected, and a potential difference of how much I have given here. I hope 26 volt. Yes, so the potential difference is 26 volt. The first question I have to solve is equivalent resistance. So equivalent resistance are S, they are in series. It is very simple. 2 plus 5 plus 6, R1 plus R2 plus R3. So they will give how much? 5 plus 2, that is 7, and 6, that is 13 ohm, isn't it? And the second question, here we have to use the V is equals to IR formula, and we have to find current I, which is nothing but V by R. The given potential is 26 volt, and the resistor, the equivalent resistor, is 13 ohm. So it will give 2 ampere. So the current flowing through this circuit will be 2 ampere. See, I can ask you here multiple questions. Like suppose, let me add one more question. Find potential drop across 2 ohm, 5 ohm and 6 ohm. Now the question is tough one, little tough, but yes, we can solve it. We have formula, we have concept, definitely we can solve it. It is nothing but we have to use the Ohm's law 3 times. How? See, first we will focus on the 2 ohm resistor. Let us focus on 2 ohm resistor. What is the potential difference here? Suppose it is V1. What is the current flowing through this? It is 2 ampere. So from Ohm's law, V is equals to IR. We have to find the potential difference across these 2 ohm. That is V is equals to IR. How much current is flowing through it? 2 ampere. What is the resistor? It is 2 ohm. That is 4 volt. That's simple. Now we want to find for 5 that has changed the color. This one. What is the potential difference across this 5 ohm? Let us take it as V2. So V2 is equals to V is equals to IR, IR2. So V2 is equals to I means 2 ampere, R means 5 ohm. So it will give 10 volt, isn't it? The third one, let us take it is V3. So V3 is equals to I is 2 ampere. Okay, let us write the formula as well so that it do not confuse you. So I is 6 ohm, R is I is 2 ohm, R is 6 ohm, I is 2 amperes, is 6 to the 12 volt. Okay, see, let us verify once again. Here V1 this, V2 is this, V3 is this. V1 plus V2 plus V3 gives 4 plus 10 plus 12. That is 14 plus 20, 12, that is 26 volt. It is nothing but this one. And we also assume this, we took this here also. You see, V is equals to V1 plus V2 plus V3, isn't it? Okay, so this is series combination. Now we are left with the parallel combination and combination or mixture of series and parallel combination. So this is parallel combination. Parallel combination. What do we do in parallel combination? Here also we have few resistors, and these resistors are connected in parallel. Suppose this is one resistor, this is another resistor, and these are connected in parallel combination. I took 3 resistor here. Okay, this is 3 resistors and they will be connected in parallel. So I connect them in parallel combination. That is their one of their one ends will be connected to a single point and the another ends will be connected with another point. Okay, now definitely I have to give some potential difference across them, which will be the reason for this electric current. Okay, so let me add here the battery V. Current will flow through this and will come out through this. Okay, so here in the series combination, our key point was V is equals to V1 plus V2 plus V3. This is actually key point in case of series combination. What in case of parallel combination? In case of parallel combinations, listen carefully or observe carefully. The points, this point is the negative terminals of the battery, and this point is connected. This is the same point which is connected to this terminal of the resistor R3. Suppose this is R1, R2, and R3. And the same point is connected to the one terminal of R2, one terminal of R1. Similarly, the positive terminal of the battery is connected to the another terminals of R1, R2, R3. It means, essentially it means the potential difference across the R1 is the same V. Let me, for the sake of the clarity, let me draw it a larger diagram. Okay. Should the potential difference across R1 is same as that of the battery? Similarly, the potential difference across the R2 is same as that V which is supplied by the battery. Similar is the case for the R3. Okay. So this is the case. So what is conserved here then? What is the key equation here? See, the current I enters into this combination, but after entering, it actually gets divided into three parts, I1, I2, I3. Why? See, V is equals to IR, so I is V upon R. V is constant for all the cases R1, R2, R3, but R is different. So definitely I will be different, isn't it? So I1, I2, I3. So here our key point will be I is equals to I1 plus I2 plus I3. Okay, I1 plus I2 plus I3. Fine. What we are going to derive, we are looking for actually the equivalent circuit, equivalent resistance. So suppose this is the equivalent resistance and we denote it by Rp, that is the parallel resistance equivalent to resistance for parallel combination. And here we'll connect the same battery and same battery V. Same current will flow, same current will come out. So in place of I, we can write V is equals to, I is equals to what? I is equal to V upon R. So V upon R means R parallel is equals to I1. I1 is what? Again, we will use here the concept of here. Here, the relation is what? What is the relation between I1, V, and R? The relation is nothing but V is equals to IR, that is V is equals to I1 times R, isn't it? V is equals to I1 times R, that is we are looking for I1. So it gives I1 is equals to V by R. I1 is equals to V by R. So V by R1. Actually, it is R1 as the resistor is R1. Similarly, for I2, it will be V by R2. Similarly, for I3, it will be V by R3. All the V's in the numerator will be cancelled out in the LHS and RHS. Finally, we will end up with 1 by Rp is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the equivalent resistance for the three resistors when they are connected in parallel combination. But this is not the general case. For general case, what do we do? We take n number of resistors. For n resistors, connected in parallel combination, the equivalent resistance is 1 by Rp is equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus dot 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 plus 1 by Rn. Okay, so there are lots of special cases corresponding to these parallel combinations, but in this session we are not going to discuss into that. But yes, we will definitely discuss what is the case for R1 and R2. That is when there are only two resistors, what will be the equivalent parallel resistance of the parallel combination? I mean, this is very, the thing is, it is useful actually. The two resistances are connected in parallel. we usually encounter in our courses. Okay, so suppose I draw it. Suppose this is a resistance R1. This is a resistance R1 and one more resistance. They are in parallel combination. This is the parallel combination of R1 and R2. Some potential difference. Okay, forget about this potential difference. Actually, it is independent. The equivalent resistance, the value of the equivalent resistance is independent of the potential difference. But yes, we do give potential difference to calculate. Otherwise, we can't calculate. Once we have calculated, we need not this potential difference. Here, what we will be doing here, 1 by R equivalent is equals to 1 by R1 plus 1 by R2 for two cases. See, what we will do here, R1, R2, you know is this well, this, isn't it? For R equivalent is equals to, it will come up with R1, R2 by R1 plus R2. So this is, sometimes it is useful. Okay, let us give some example related to this. Example, we need example, otherwise numerical example. Find equivalent, sorry, to save the time I am writing speedily. That is why the handwriting is not that good, but yes, I can write actually good with good handwriting. Find equivalent resistance of 5 ohm and suppose 15 ohm when connected in parallel combination. Okay, what will be the solution? Simple. For as here we have only two resistance, so I'll use this formula. 1 by R equivalent is equals to what? Nothing but we have to just multiply, and in denominator we have to add. Okay, so 5 times 15, and in denominator it is 20, so 5 4 is 20. It is nothing but 15 by 4 ohm. Okay, so this was all about the series and parallel combination, and we will at least give one example corresponding to the mixture of series and parallel combination. Mixture of series and parallel combination. Okay. So, I mean here the resistances or the resistors will be connected in both series as well as parallel. Okay. For simplicity, I give very simple question. This is suppose R1 and this is suppose resistors R2, and here the resistances R2 and R3 are in parallel. This is point A, this is point B, and this is point C. What is the question here? Find equivalent resistance between, let me ask it the question in two ways. Okay, forget about it. Let me be very straightforward between A and C. Okay, this is the question. Solution, how to solve it? This is very simple. See, let us, we can solve it. We finally we have to solve the resistance between A and B, RAB. Can we write it as RA? Sorry, we have to find it between A and C. Can we write it as AB and the resistance between BC? Definitely we can. What will be the corresponding circuit? This is R1 and focus on the point B and C. There are R2 and R3. They are in parallel, isn't it? They are in parallel. So let us draw this. Let me use different color. For this part, our task will be first, we'll find the equivalent resistance between BC, RBC, or we can write R parallel as I taught you, R parallel, and this is the point. So this is point A, this is point C. So what is RAB? We know it is nothing but, okay, let me give some numerical values as well. Suppose this is 1 ohm, suppose this is 3 ohm, suppose this is 6 ohm. Okay, so RAB, which is nothing but R1, that is 1 ohm, plus RBC, which is nothing but RP. Let me use the same color, otherwise you will be confused. So this is 1 ohm. And what about RP? This is the parallel combination of 3 and 6. Let me write in this way, 3 parallel 6. Okay, we do represent this way sometimes. And 3 parallel 6 ohm, we can write it as 1 plus, what about 3 parallel 6? It is nothing but first we multiply, in denominator we add them, isn't it? So it gives 1 plus, 3 multiplied by 6, in denominator it is 9. So if we divide, it will give 3 3s are 3, 3 3s are 9. So 3 3 2s are, so 2. So it is basically 1 plus 2, that is 3 ohm. Okay, I can give you many more complicated circuits, but in this session I want to conclude here. I hope you have understood all these. If you have not understood, do contact me through Urban Pro profile, and it's here. That's all for today's session. See you in the next session. Okay, bye.